Hello, in this video I'm going to do two more examples of sketching graphs using DRT and the four labels, and as promised one will be an exponential graph and the other will be a log graph. So let's start with an exponential graph. I'm going to do f of x equals negative 3 e to the power of 2x plus 2, and I've just mixed it up a bit here using functional notation. Alright, step 0 is to make sure that the coefficient of x is 1. We've got a 2 here, so no, it's not 1. Let's change that by factorising. Now it's 1, now we're good, now we can do dilations. Let's look at the dilation. Alright, we have a factor of 3 here, so we have a dilation by a factor of 3 from the x-axis. Over here we have a factor of 2, but that's near the x, so that's going to be dilation by a factor of 1/2 from the y-axis. Next we have reflections. Yep, we do have a reflection. We're flipping this in the x-axis. Reflection in the x-axis. Remember, use any chicken scratch notation you like. This is what I'm using. Use what you want, what works for you. And translation, well, that's 1 unit to the left. Alright, let's draw our mini graphs. So starting with the basic shape of y equals e to the x, we've got a dilation by a factor of 3, which is going to make it look something like that. So move it away from the x-axis, and the dilation by a factor of 1/2 from the y-axis is going to stretch it in a bit tighter towards the y-axis. We have a reflection in the x-axis, so that's going to flip it upside down. There we are. And a translation of 1 unit to the left. So our asymptote's going to be there. Our asymptote's not going to change, but it's going to be moved 1 unit to the left, which is going to affect our y-intercept. Alright, now we know what features we need to find. We know what 4 labels we need. We only need 2 of them. There's definitely an asymptote here, and we can see that asymptote hasn't changed. We can see that it's at y equals 0. Okay, so the asymptote hasn't changed, but we're going to have to find this y-intercept here. We don't know what this thing is. Let's find it. Y-intercept, make x equals 0. Well, f of 0 equals negative 3 e to the power of 2 times 0 plus 2. So we have negative 3e, well, 2 times 0 is 0, plus 2 is 2. Negative 3e squared. If we were to roughly work out what this is, e is about 2.7, so let's pretend it's 3. 3 squared is 9. 9 times negative 3 is negative 27. So it's less than, or greater than negative 27, but we're going to leave it like that. This is called exact form. We're going to leave it in exact form because if we were to write it as a decimal, it would only be an approximation. In methods, we like to be exact. So unless a question says give the answer to 2 decimal places or 1 decimal place or as a whole number, or unless it's specific, assume that it wants exact form. So that y-intercept is going to be 0, negative 3e squared. There's the y-intercept. And the asymptote hasn't changed. The asymptote is at y equals 0. And we have our DRT to thank for revealing that. Well, we've got all our information, so let's sketch a graph. I'm going to be very good. I'm going to grab a ruler, so should you, and I'm going to make my axes nice and big. As always, make it big. Don't make it small. You don't want to have some little shy graph. You want to show you know exactly what you're talking about. You want to have lots of room to label your features, and you want to make sure that you make your asymptote super clear. So I'm going over the x-axis again to make my asymptote super clear. Then let's sketch. Well, we're not going to touch the asymptote. I'm going to draw carefully. It's going to do something like that. You can see it's not the best there. I'm going to have another go. Get your graph drawing as perfect as you can. Alrighty, that point there, as we figured out earlier, is 0, -3e squared. And let's label it. Let's be super fancy and label it with our equation. And there's a graph of an exponential curve. There's your answer. That's an exponential curve. Let's look at a log graph. A log graph. So I'm going to make up an equation of a log graph. My equation is going to be y equals 7 ln. Remember, ln is log base e. So another way to write this equation, I'll give you a quick note over here. Another way you might write this is, well, it's equal to 7 log base e. -5x. Sorry, -5 minus x. These mean the exact same thing. That stands for natural logarithm, log natural, ln. Step 0. There's a negative sign there. We've got to factorize that. Let's get rid of that negative. And once again, I like to flip these around just because it looks nicer to me. So we've got 7, the natural log of -x plus 5. Now we're looking good. Now we're rolling. Let's look at the dilation. Definitely by a factor of 7 from none other than the x-axis. Reflections, you betcha, that's a reflection in a y-axis. Hopefully you're getting quicker at these. Hopefully they're just popping out at you. And we've got 5, well, that's 5 units to the left. Let's do our mini graphs. Well, the natural log graph, it's the inverse function of the exponential graph. So it's going to be something like that. Dilation by a factor of 7 from the x-axis is going to do that. So it's the x-intercept is going to be more to the right. We have a reflection in the y-axis. Bam. We're over this side now. And we're moving 5 units to the left. Alright, let's move 5 units to the left. So that's going to move our asymptote there. So our asymptote's gone from here, it's popped over 5 units to the left as well. You've got the basic shape. What of the 4 labels do we need to find? Well, it looks like we just need to find the x-intercept there. So let's find the x-intercept by making y equals 0. 0 equals 7 natural log -5 minus x. This is going to test your understanding of log laws. So we're going to divide both sides by 7. 0 equals natural log of negative 5 minus x. Okay, so I'm going to do a quick side note for this because I remember we slipped up on this a bit. So if you have, I'm going to put this, so if you have log A, B, C like that, that's the same as writing a to the power of c equals b. A more familiar way to look at it would be if I have like 10 squared equals 100, the way I would write that as a logarithm is log 10, 100 equals 2. In other words, what power do I raise this number to get this number? Well, that power is 2. 10 squared is 100. 10 squared is 100. So over here, I'm going to use this rule here. And I'm going to work up here. Let's use the rule. So that's going to be e to the power of 0 equals negative 5 minus x. Anything to the power of 0, provided it's non-zero, anything to the power of 0 is 1. Ta-da! And then we're going to add 5 to both sides. 6 equals negative x. X equals negative 6. Beautiful. We've got our x-intercept. Negative 6, 0. And we know our asymptote, well, it's been translated 5 units to the left. So we know our asymptote is the line x equals negative 5. We know that because it's gone from here. You can't dilate an asymptote. You can't really reflect an asymptote, can you? But you can translate it. Have a think about that. See if that makes sense to you, or else just accept it for now. In this case anyway, you can't do those things. There are other crazy asymptotes. They don't necessarily have to be horizontal or vertical. If you're doing specialist maths, you might encounter asymptotes like this, or like this. But for now, we just worry about the translation. We've got all the information. So what do we do next? Well, we sketch it. We've got the asymptote, we've got the x-intercept, we've got our equation. Let's go for it. I'm going to make a point here. I'm going to make my axes giant just to prove my point. No, that's not good enough. I'm going to make them giant. Because I hate seeing puny graphs. I hate puny graphs. And so do your examiners. They hate puny graphs. Don't give them puny graphs. Draw big graphs. Need to put in our asymptote. So I'm going to grab my ruler again. Asymptote's going to be somewhere over here. There's the asymptote. And it was at x equals negative 5. Great. And then our curve went something like this. This is really hard on a tablet. I'm going to try again. Alright, I'll accept that. And our x-intercept, I'm doing this from memory by the way, so that was when y equals 0 was at 6. It was 0, it's negative 6, 0. So, yeah, we've got all our features there. We don't really need to put another point in for the dilation, but if you're good, you can do that. Let's write the equation. Hopefully I remembered it correctly. 7 natural log negative 5 minus x. I'm going to do a quick check. So let's see, the asymptote's at x equals negative 5. So I'm going to show you how I check this. Well, that's when this stuff equals 0, because you can't have log of 0. It doesn't work. So let's check that. Yep, I got my asymptote right. Let's check the x-intercept again. Make y equals 0. So get e to the power of 0 is 1. I always like to check things 2 or 3 times. I know it sounds crazy, but small mistakes on your exams cost you a lot of marks. That's your answer. Alright, how do you check your answers? I haven't given you answers for the worksheet. There's one answer to that. You can go to desmos.com. It's a really intuitive graphics calculator online, and you can check your answers there. Or please use your CAS. So if you use one of these two, then checking the answers actually becomes a learning opportunity, because you also have to learn to use your CAS. That's why I haven't given you the answers. And if you have been, thanks for watching.